Modulation also produces high frequency noise from motors, which can be efficiently radiated by the stator or within the inverter housing. So down here, this is another color map. So we have frequency here, and we have time here, but time is proportional to the speed of the motor that we were looking at. This motor had a switching frequency of 10 kilohertz, and we see that it had various different strong, let's call them, they're like order lines in that they're diagonal, that emanate out. So what we see is a central line that kilohertz, and then we see higher frequencies and lower frequency lines due to the modulation. Earlier I kind of pointed out how those are due to varying the load cycle as we vary the speed of the motor. So you see some of them go left, some of them bend right. If I wanted to look at what causes those, this is a color map of the current of one of the phases of that motor, and this is a color map of the voltage of one of the phases of that motor. And if you were to look at this line or that line, you might notice that this line does not have a strong current counterpart, but it does have a strong voltage counterpart. And another line might have a strong current counterpart, but a low voltage counterpart. This is kind of one of the areas that we have ongoing research right now to kind of think a little bit more about why sometimes noise is associated with current and sometimes it's associated with voltage. But we have seen a strong need for an NVH engineer to be able to measure these high voltage signals and high current signals at the same time, and it's the same measurement system. They're measuring the microphone and the accelerometer signals. And this can be done with with our HBM Genesis system. It's already configured to acquire voltage signals up to 1,000 volts, and it has high current probes. So it's very fast, so it can really capture a lot of the detail that's going on here, while at the same time it has CCLD for providing inputs for accels and microphones. Sorry, that we got a little bit commercial there, but it's worth noting this is kind of a unique capability product that we have. And one of the reasons to do that is just, going back to the slide that we looked at much earlier, it's important to note that actual control doesn't always match your intended control. So by doing this, the noise engineer can work with the control engineer to find the best compromise of efficiency and performance and noise. Kind of like way back in the day when we started having direct injected diesels, and the noise engineer had to work closely with the controls engineer there to adjust the pulse cycles for the direct injection electric injection diesel. As far as the role of NVH engineers go, will we be redesigning motors? Probably not. The motors will be designed using tools, and it'll be set. We won't be putting treatments on the rotors to make them less noisy, because motors don't like having things put on them. They need to run cool. They don't like to be wrapped or have patches put on them. Will we be providing value judgments of noise and vibration of the motors? Yes, we will. We'll be setting targets and saying which ones are good ones and which ones are bad ones. We'll be screening for quality defects. We'll be identifying potential control issues, as we just discussed, and integrating the motor into the vehicle. Will be our roles in the future. A paper on integrating the motor into the vehicle is one by my coworkers, Brian Tome, Todd Freeman, and Scott Smith from Toyota. And one of the things they found was, even though it seems like it should be very easy to put an electric motor in an existing vehicle, there are three main challenges they saw. The reduced weight of the motor and the higher torque mean that we've got higher mounted natural frequencies of the motor. So there's more modal coupling and forced response issues than with the internal combustion engine. There's a different frequency signature with the electric motor. They did a jury study, and they found the higher motor made, the less customers liked it. And then you also have the mounting strategy for accessories. In a ICE car, it naturally produces the vacuum that you need for the brakes, and it has the water pump mounted to it. So taking something and mounting it to a 400-pound or a 300-pound hunk of aluminum, and then having that isolated by engine mounts from the body is a very good isolation strategy. When you take that same water pump and you put a couple grommets on it and you bolt it to a panel on the body, then you have a challenge.